So the above examples were what we call restricted solutions. Now, generally speaking, when we look for a restricted solution, it's within one revolution. But really what we're saying is we're only looking for theta within a specific domain. So what we're going to do is we're going to alter the question so that we're seeking all possible solutions. So when we seek all possible solutions, this is known as the general solution or general solutions. So when noting all possible solutions, we have to draw up on our knowledge of coterminal angles. General solutions will imply radians unless otherwise stated. So I am going to solve for sine theta is equal to 1/2, where theta is element of the reals. This question, especially this one, means let's find all angles. And it implies radians, since it's the general solution. I start off my question exactly as I did before. And here we are, and here we are. Where is sine theta equal to 1/2? Well, in those two places of blue marker, but I'm going to make one blue and one purple. So really, I can think of it like this in the following way. Theta is equal to, well, it either has to terminate at the blue mark or at the purple mark. What are all possible angles at the blue mark? Well, those are angles that are coterminal with pi over 6. Well, what are the angles coterminal with pi over 6? Pi over 6 plus k 2 pi. Now, I'm just going to put qualifier that k has to be an element of the integers. Now, the purple, well, it's in the pi over 6 family, but the related angle in quadrant number 2 is 5 over pi over 6 plus k 2 pi, where k is element of the integers. And coterminal angles, or general solutions, they follow this process here, right? So the first block, if you will, the first term, is a location of what angle that you're talking about. The second block is an indication of the frequency or period of how often or how long it'll take to get to the other angle. So if I'm talking purple, well, how do I go from purple? I have to go to pi. And remember that probably a way of saying how do you get to the purple is, well, it's 5 pi over 6 plus multiples of 2 pi. Anyways, that's what my solution looks like, and I'm describing all possible angles. All right. Example 5. Solve tan theta is equal to 5 for all theta. Now, for all theta, again, I'm implying general solution here. And what do I know for sure? General solution, it is in radians. I look at this question and I see that tan theta is equal to 5. Well, I don't know that one, so it must imply approximate values. So I'm going to need my calculator. So tan theta is equal to 5 in quadrant 1 and quadrant 3. Tangent theta is positive in quadrant 1 and quadrant 3. So I'm going to have two answers. So what I'm going to do now is I'm just going to say theta is equal to, and again, I'm going to use the same process, the blue angle and the red angle. So what is my blue angle? Well, if tan theta is equal to 5, I can simply take the inverse tan of both sides. So I get inverse tan of 5, and what I get is theta is equal to 1.373, rounded to 3 decimal places. So that's really my theta 1. My theta 3 will just simply be 1.3734, that big long string that's in my calculator, plus pi. And if I add pi to that number, sorry, having calculator issues. What I get is my theta 3 is equal to 4.515. So those are my two answers. And by the way, I've rounded that to 3 decimal places. Going to have to round that out. So I'm going to talk about the blue solution, which is my quadrant 1. So the location of my solution is 1.373. And then how long will it take for me to get to that solution again? Well, every multiple of 2 pi gets me there. Now, what is my theta 3, or my red solution, my pink solution? It's going to be 4.515 plus k 2 pi. Now, k is element of the integers. You think I'm done. This is 100% correct. Best of my abilities. But I can also think of it a little bit more clever than that. Now, theta is equal to, well, what's my quadrant 1 solution? Well, it's 1.373. But if I notice, to go from my quadrant 1 solution to my quadrant 3, I simply go 1 pi away. To go 3 to 1, I go 1 pi away. To go 1 to 3, I can go 1 pi away. Or I guess I can say 1.373 plus every pi away, k pi, where k is element of the integers. All right, I hope you found this informative. Stay tuned. I'm sure math will continue to delight.